All right, hello again and welcome to the webinar. My name is Timothy Carlin. Joining me in a few moments will be Timothy Winters. Today we're going to be talking to you about automating your testing with IOL INTACT. This is a first in a series of webinars that we're planning to host about once a quarter, every 3 or 4 months. For each webinar, we'll highlight a different feature of the INTACT software, as well as looking at the different protocol testing packages that are available. We appreciate you joining and know your time is valuable. We hope to make these a lightweight and informative talk and to get to the point quickly. With that in mind, we just have a short agenda that should take us around 45 or 50 minutes to get through. First, we're going to go through a brief overview of the architecture of the software and the various components, as well as reviewing the different protocol packages that we make available to our customers. Then we'll take a deeper dive into the software itself, and I'll demonstrate the configuration and setup, and we'll run through a test or two. Following that, I'll hand it over to Timothy Winters. He'll show us how we can integrate shell scripts with the IOL INTACT software to deliver full device testing automation. Lastly, Tim will demonstrate one of the newer components of the IOL INTACT software, the command line interface, or CLI. At any time, we encourage you to ask questions via the chat menu in the meeting window. Marion Dillon and Michaela Newcomb are working behind the scenes to collect any questions that are asked, and we'll pause at various moments during the presentation to answer as we go. And we'll also take a look at them at the end. So let's jump in and take a closer look at the software. Hopefully everybody can see the slides and is hearing me okay. Please let us know if that's not the case. Again, we'll take a look at the agenda here. Introduction to INTACT, packages and protocols, the setup, automation, and then the CLI. So a lot of you may already know IOL INTACT is our custom software test tool and API. It's been developed to meet the needs of higher layer protocol-based conformance testing. We use it for testing across many different spaces at the IOL, including IPv6, routing, home networking, among a few others. So here are some of the key features of IOL INTACT. Of course, the first one is automated testing and results reporting, and this is mainly driving towards continuous integration and regression testing. Secondly is the setup flexibility. It's a typical client-server architecture, so the IOL INTACT application itself acts as a client and connects to a server, also known as the packet generator. And lastly, there's a third component, which is the license manager. That manages the number of concurrent instances of INTACT that are running. INTACT tracks the progress of all of your test runs from one run to the next and across different test cases. This allows you to compare different runs for the same device, and also allows you to easily switch between devices to compare results that way as well. It saves the logs, captures, and other interesting information about each test run, including the result, and it makes it really easy to export and report on those. As I mentioned, the floating licenses are available to allow for users to easily share IOL INTACT among different desktops and from different locations. Depending on the number of licenses, multiple users can test simultaneously using the same packet generator or using different packet generators, and can test multiple devices at once. Lastly, we note here the PDF and HTML reporting to make it easy to share the results of your test runs with those who don't have INTACT installed. There are a couple of different test programs that are being supported by INTACT. Basically, it was commercialized in 2012 to allow vendors to pre-test aiming towards full compliance with these certification test programs in-house. Being able to do this pre-certification in-house speeds up the overall certification timeline. The packages offered are IPv6 Core, IPsec, and IPv2, and CE Router. And these are looking at the IPv6 Ready forum and NIST or USGV6 specifications. Here again are the current offerings in the form of protocol packages and the RFC coverage. Again, it's used, and for each of these, we cover both components. So for IPv6 Core, that would cover both host and router testing. For IPsec and IPv2, that covers both end node and gateway testing. CE Router is, of course, just the CPE device. and OSPF and BGP would be for routers. The system requirements themselves are actually pretty lightweight. Any relatively new Intel or AMD processor would work fine. Pretty low memory requirements on the hardware itself, and the storage is actually only relates to how many results you might want to store on the PC at any one time. Most of the modern operating systems are supported for the Intact client application, and the server or packet generator runs both CentOS and Ubuntu. Actually, in a lot of cases, we find that our vendors do well to install Intact on a virtual machine. Typically, we see that installing the packet generator at least on a virtual machine makes a lot of sense and is pretty flexible. This allows you to install the application itself on your PC, be it a desktop or laptop, or even you could install it on the server and do a remote display. But there's a lot of flexibility there, and here's another picture of that flexibility where you can see the different components. And what we're trying to show here is that you can have multiple client applications connecting to one or more packet generators or servers. Each server is typically connected to one device under test, but that doesn't preclude you from connecting multiple DUTs to the same server or any combination thereof. The other thing that's being displayed here is that the client applications are going out to the license manager to request licensing and startup. The license manager is delivered as an IOL virtual machine. We're making that more lightweight than it even is today in the form of an Ubuntu PC that really makes it easy to deploy and set up. So that pretty much covers the overall components and architecture of IOL Intact. At this point, we'll switch over to the application itself and see if we can run some tests. So here we see the Intact client application. It's already started up. There are some results that have been collected already for this particular device. And I'll just walk you around the GUI really quickly here to give an overview. In the top left here is the test results chooser. In this area, you would select which test result set you wanted to look at any time. We find that a pretty good organization scheme here is to organize by device and by protocol. So when you want to test a different device or test a different protocol for the same device, it makes sense to load a new result set. Here you can specify a test label and the playlist you want to load, and where you'd like to store that. By default, we store all results in the IOL Intact workspace. Load existing is something we typically only use internally because everything that's already in your workspace should be preloaded in that pull down. When you hit go, you get a display like this. In our case, since we already had results, it would show us all the runs for that. On the right, it shows the playlist that's loaded. So we'll take a look at the configuration. It's pretty straightforward. In the upper left hand, again, we have a chooser to select the device that we want to test. And you can name or rename these devices. There's a few different settings here that we have to go according to testing. The server address and the server device relate to the packet generator. The packet generator is specified either through an IP address or an FQDN. You also need to specify the port that the packet generator is running on. And that's a command line option. We also have a web interface for managing the different servers packet generators. The server device, net0, in this case applies to the interface on the packet generator that is directly connected to the device under test. Next, we have some information about the DUT itself. And there's a few things here. The first one is the MAC address of the DUT. Again, this is the interface that's connected directly to the server or the packet generator. Next is the link local interface ID. This is the identifier that is appended to the FE80::: prefix that are used for link local IPv6 addresses. Next, we have the global interface ID. On some devices, these two interface identifiers are different. In some cases, they are the same. That's the reason for the flexibility here. The next field is the automation field. With this field selected, it enables device automation, which Tim will get to later on. Device driver is something we use internally and can be safely ignored by our users, as can the next three options that are typically fine when left defaulted, but you may find in some rare situations that playing with these options will yield better results for testing. Lastly, down below is the capture configuration window. This defines how Intact is going to automatically save packet captures. You'll notice that the server IP and the port match the table above, as does the interface. The filter is a TCP dump or libpcap style filter, and typically we find that setting it to IP6 for IPv6 makes for clean captures. You could further specify it or delete it entirely. That's pretty much comes down to user preference. At this point, we can close and save the capture, close and save the configuration window, and go back and take a look at a couple of test runs. So let's go ahead and start it. You'll see here when I click start, the button grays out to prevent me from double clicking. We notice that the star around the IOL logo starts spinning to show that a test is running. We get some status updates along the bottom. Progress bar shows 100% at this time. And we may have been hard to notice the difference here because the test passed and it had passed previously, but the time did update here. Shows that it was run today, June 6th, 1412. If we double click on it, it'll bring us directly to the test details for that. And here we can see the logs and previous runs for this test case. At this point, we could change the results, either confirming it or overriding it. Of course, it was a pass in this case, so we'll leave it at that, highlighting it if necessary. Also in this window, along with the logs, you can get access to the packet capture itself. This is the packet capture collected by Intact during the test run. And here you can see the echo request from Intact and the reply. So this test case is a pass. The remainder of these packets, as indicated by the cleanup MAC address, target link layer address, are just for reinitializing device and preparing it for the next test run. From the run summary, you can select any number of test cases like you would expect by clicking and dragging or using the Shift or Command or Control keys. Also from this screen, if you were to select multiple tests, you can right-click and select to highlight, or leave a note for yourself to go back and rerun these test cases. Makes it easier to change these test cases in bulk, especially when you have a lot of them that you're looking at. So that pretty much covers testing with Intact from the base point of view. There's a couple of other features, including looping and other things to explore, from generating the different reports, HTML, PDFs. Oh, and while we're here, one thing I didn't point out was the messages. It's generally not the most useful. It's mainly there for developers. But one thing that is nice from the view window is the results statistics window. This is a newer feature here. What we're trying to do with this window is give you a metric for how well the device has performed over time. This is probably most useful if you have a new device running some code that you expect to improve over time. So when you first ran it, in this case, the device hasn't changed. We haven't changed the code or tried to change the test scripts themselves, so all the tests are the same. But where this could be useful is to show that in your oldest run, you had maybe several failures, And as it became newer and newer and you made new updates to the code, more tests began to pass. One other thing I'd like to point out while we're here it's helpful for us to see the logs as you see them. And the easiest way to send that is to send us what we call a debug zip. What you'll do is go to the help menu here, click on Make Debug Zip, and we'll do exactly that. We'll create a zip file containing all of the results and log information that we would need to help you debug your test cases. At this point, I'd like to hand it over to Timothy Winters to go through how we do device automation with the IOL INTACT software.
Hi guys, this is Tim Winters. Thanks Tim Carlin for starting us off there. So I'm gonna talk a little bit of housekeeping. There is a Q&A button. If you would like to ask us questions, feel free to click on that button, write your question in there. We're gonna take some at the end. So please feel free during it. If you have a question, we can backtrack. We have all the software here. So please feel free to write a question. So I'm talking today more on the automation side of things. The first half was just to sort of recap what we've done. So I'm going to start with the most common test case in core. This also applies to our CE router crowd out there. In CE router's case, it's much more about rebooting the device because that's a zero touch test case. For core automation, you can run 80% of the test cases, but then there's a set you need to automate. So I'm going to run this test case, and it's going to pop up a message to me saying, hey, can you initialize the interface? We need to do DAD. This is the most common test case. So for this, I'm logged into my device. This is the address of it, and I'm going to do IP link set test. Yep. Type out that down. So I had to SSH into my device. I have to log in. The message window disappears at that point because I've done what I needed to do, and it'll stop in a second. So the bad news there is I had to be sitting here the entire time for that test case. I had to log in. I had to bring the interface up and down. Test case passed. This time I'm just going to do another one. So it's okay. I'm going to do the next one, but hang on. How many of these are there? There's a lot. All right. So that's not fun. So we're going to come up with a better way. I'm going to go ahead and clear that one real quick. So this is our methodology for allowing people to automate these test cases, right? Our intention is not to have users sitting in front of INTACT to do these continuous tasks over and over again. For CE router, the one we're not demonstrating today, it's very similar. We have a reboot script in that case, but I'll talk a little bit more about that. So over here, we have this auto button. When you want to implement auto, you should check off the button. That means you've enabled it. A couple things you want to check when you do this. You want to check the properties window. What's important inside of here is the automation scripts. So in this case, we've set it to a directory called IP automation scripts. So right here, I have a directory. Here's this window. And it is IP testers. So this is the script. So inside of here, we have a script that we call, we also supply you with a template to this called exactly this name, IPv6.sh. What this is this is a shell script that we give out to anybody to basically implement the functions that we need. So a couple of things to keep in mind here. We did bash shell on purpose. In our case, we did that because our customers said there are many different environments with lots of different ways. Obviously, you can use a bash script to call Python SNMP. That's very common for our CE router. They use SNMP resets either to a power device or to the device itself. For IPv6 testing, we've heard Python, Tickle, expect. Here at the lab, we use expect. So we basically go off and call an expect script, then we insert whatever different devices have different expect drivers is how we do it internally. So here we've written a little DAD enable function. What it does is it says, okay, two different interfaces. The reason this one takes two arguments is because if you're testing an IPv6 enterprise router, you need to bring up either interface. So we just wrote it up. In this case, we're testing a host, but we basically indicate you get two different functions. And then in this case, we just SSH into the device we're testing, and we bring the link down and up just like I did. So in this case, you'd write in whatever scripts you needed to do. We also, for a host, have clear path MTU enable. That one's a bit trickier. I didn't demonstrate it today, but path MTU can be cleared lots of different ways on a device, and this is one of those areas you got to know your device. Typically, it's rebooting, bringing the interface up and down. Routers will have a command occasionally that lets you clear the IPv6 cache. And then the last two are pretty self-explanatory that we use for this one. It's link local ping and global ping. As you can see, we basically write out the device drivers. As Tim mentioned earlier, you can basically skip these first commands, we'll parse out, but after this point, these are the things you may have to implement. So for ping, for example, you might have to do the destination, and then you might want to implement the count, the size, and where you store that file. You don't need to do all of those. So in this case, the angle brackets, sorry, the square brackets are optional. So in this case, you really only need to do destination, but there are cases, for example, when doing path MTU, you need to give it the size of the ping. So back to this test case, we've implemented DAD enable. It looks like this. In this case, I'm just going to go ahead and run it by hand real quick to see. Oh, I didn't give it the right stuff. So here we're going to do device 1, DAD enable. Oops. So there it called the right number. It said, yep, nothing blew up on me. So in this case now, I know that my script actually works inside. It called it, it echoed it all back, it logged in and did the device. Now let's see if it works over here. So here, we're gonna go ahead and run 312B. So in this case, actually for a moment, I'm gonna rerun one that we ran previously just to make sure it works. So that time you saw it pop up and immediately go away. I didn't do anything. It logged into the device and brought it up and down. So now, I'm feeling good, feeling lucky here. I'm gonna go ahead and click on a couple of these. Let's do this set. Let's do these guys afterwards. So now I can run lots of test cases in a row. It'll go off and run them. And as you can see right now, it's going to pop up this message over and over again telling me to do DAD enable. C router is very similar. It does the same thing. It enables it. C router in the future is going to have other functions such as release, confirm. The next release of those will be automated so that users can go in and do some of the manual configuration. We originally wrote it for zero config, but C router, we've gotten the request from several people to implement those other features, so we'll be doing that. Yeah, and I'll take this moment. We're obviously open. We like feedback. So if you have any questions, you can email intact@iol.unh.edu, and that will get us access to us. And then, as Tim mentioned, send us a debugger if you're actually having problems. Most of you we've contacted directly, so it shouldn't be a problem. In this case, as you can see in the background, the test case is running pretty straightforward. So now that I've got it set up in the GUI, I'm going to show off the CLI a little bit. So right here we have the CLI, which is launched by Intact. I went into the user bin where I installed Intact, and I just called IOL Intact CLI. As you can see, we're running this on a Mac. This will also run on a Linux, sorry, not Windows. It'll run on a Linux box, no problem. So right here, I've launched the test case running in the background. So first thing I'm gonna do is just show you guys the menu real quick. It's pretty straightforward. The first thing you're gonna wanna do is do ls, and this lists all the test results. At the moment, it shows what's currently running, so I finished these test cases. What I'll show off at first, if I try to log into something the GUI has open, it throws this little error saying, hey, somebody else is using this. This is really a locking situation where only one person can be writing to it at a time. So I'm just gonna go ahead and shut down the GUI at this point. So now I'm gonna try to go into those results. So right now I've logged in CD into that. LS lists all the available results you have, and then this logs you into it. Inside of here, we have a set of commands. Again, question mark gets you them. I'm going to start with just info. This is where it'll list the number of test cases run, fails, those kind of statistics, as you can see. Also, the labels are up here. You're going to want to use these for running individual groups of test cases. So once you have the CLI, this comes up. You can see the individual ones. There's also results, which list the individual results that you'd want to see. This is kind of harder to parse, especially for the larger ones, but it is there and available to you. Let's see what other commands. So I'm just going to go ahead and do start, and I'm going to rerun some of those DAD test cases again. So if I do start DAD, what happens is it's now running in the background and it marks it as running. So in this case, you can do status and it will show you the individual test cases that are running at that individual time. So it's now running in the background. Testings now can run, so you could, again, this is a situation where you could script your own thing to turn on the CLI, CD into a directory, start the testing, running overnight. Also, one CLI can support, if you have licenses for multiple seats, it will support running multiple testings at a time. So if you have 2 licenses, you can run 2 testings at a time, or 3, however many you'd want to run based on the number of licenses you have. So in this case, what you would do is you would CD up out of a directory. So let's see, I don't want to close it. I just want to switch. So here, it gives me a little message saying, hey, it's still open. And if I do an LS, it gets a little star. But if I wanted to CD into a second device, I could log in and see its info, right? And I could start testing from here, see how it's going on with it. Nothing's going on, or this testing's done. Let me go back to the other one. If I want to close the session so that I can open it up again in the GUI, I just do close, and that takes me out of the session. But it keeps the other one open that's currently running testing, so let's go back to that just so you can see it. And then again, status, as you can see, it ran 4 test cases while we were off doing that. So the CLI is much more powerful when it comes to being able to run automated testing or nightly testing. One thing I do want to add is going forward, we're going to continue to push that. That seems to be where a lot of our requests are coming for regression continuous testing. So I think in the next year, you'll see a version of Intact that supports RESTful API type calls so that you can call it directly without having to start the CLI, those kind of things. So that's sort of the direction that we're headed with Intact, and I think you'll probably see a webinar in the future about those kinds of features as they come along. If anyone has any questions, feel free to prime them up now. I think we've shown most of the features we wanted to show, including how to IPv6.sh, all of the scripts are in there. The arguments are parsed there. Also, some of our customers, if you're working with us for testing in-house, in particular for the US government, since it's required, or any ISO testing for Anatel, if you send us your IPv6.sh, that speeds up our testing. So if you've developed something that we can use and you can send us that file, we'll just upload it and run testing. It's clearly faster for us to do something like that. It keeps us working together. We know the commands. It'll just run out of the box. So do send us those scripts as you get them. It's very helpful for us when it comes to automation type questions. So one question we got is a single license, how many users does that restrict you to? So the way it works is we have a floating license server, and the way that works is it allows 1 user per license to be running testing at a given time. So as you can see, I'm running testing right now. If I wanted to start a second session, I would need a second license that would allow you to check out that testing. What you can do is one user can be running testing while another one is reviewing results. You can ship off the results or open Intact, but it's really when you click the start button that it goes to check out a second license. So it's really per seat, per usage, per user. So a common one we'll get with the floating license is sometimes different users will have, for example, 1 user in California, 1 user in on the East Coast, and they'll share a license where only one of them can be checked out at a time. So the way that works is when the client launches, it goes and talks to the floating license server and checks it out, which allows multi-site, some people remote to check it out, run testing, no problems, that kind of stuff. So the floating license allows for you to check it out and run it as long as you have a connection to the license server.
There's another question to ask, this is Tim Carlin again, about the coverage gap between the tests that we include in IOL Intact versus the different certifications that are available and that Intact supports. And to answer that question, it really comes down to the particular certification program. Different certification programs have different requirements as far as how those results are collected and reviewed. In the case of IPv6 Ready, anyone is welcome to run task cases and collect the results for both conformance and interop and submit them to acquire the logo. That can be done in-house. It just needs to be reviewed by an appropriate lab. In the case of some other test programs like USGV6, those tests need to be done in an ISO 17025 accredited facility. So what Intact gets you in that case is pre-certification testing. It does include all of the test cases you need to pass, so passing all the test cases in Intact gets you a pretty good assurance that you will get through the testing at the IOL. Of course, there is still interoperability testing to run, but again, you should have a pretty high level of confidence that that will run successfully as well. There is no coverage gap in the tests included in Intact, but the different certification programs have different requirements.
So in the case of a direct connection, one of the questions we got is how does the IPv6.sh work in the case of a direct connection? So in this case, the .sh file sits on the client machine and it needs some way to tell the device under test to come up and down. So typically, you have the DUT and the Intact packet generator that are two separate boxes, and the client is a third box that needs to talk to it. So let me see. On this picture right here, this is a good one to show. So the client needs to be able to talk to the blue box needs to be able to talk to the device under test in this case. So we just need some sort of methodology to talk to it. I know of some customers who use their own command line. They serial directly into the device because it has a direct connection. Really what, in this case, we have a dotted line that goes from the client to the device under test to tell it how to do things. In some cases, we've heard of users using things as web browser, whatever interface they use for automation purposes comes up, and they can use that for connecting it. Again, we just have a bash script. A lot of people do a lot more complicated things when it comes to think SDN or any type of management interface that you can kick off some sort of automated script to be running in the background to configure your device.
So another question came up regarding the license server. It's a great question. Actually, the feedback we've heard from a lot of our users is that oftentimes the test network is offline, is not connected to the big I internet. So that makes it difficult to do any license checking out from the IOL facilities. So actually the license manager itself is software running on a virtual machine that you would install on your premises in your infrastructure. It could be completely disconnected from the internet, and that's okay. At the beginning, when you first license the tool, we'll do a simple 2-round pass with email. Basically, you'll generate for us a host identifier, and from that host identifier, we'll create the license that you can then install on the virtual machine to hand out the floating licenses. So this makes it nice. There is no internet connection required, and you can do all of your testing completely offline in your lab that has no outside connection. So actually, that is the only way of licensing. There isn't an option today to connect to an off-site license manager at the IOL. With that said, another question that comes up from time to time is, again, referring to the different locations. Some companies have, East Coast and West Coast locations, or a US facility and an international facility. And they ask, can we share the same license server? In that case, it depends, is the answer I usually give. It depends on most likely your connection speed to your different sites. If it happens to be pretty fast, you maybe won't have any issues with it. But you'd also have to keep in mind any firewalls or any other restrictions on the data between those sites. So typically we recommend 1 license per server per site. So yeah, I came up again just now about what ports need to be open for a site that has a firewall between sites. Off the top of my head, it is 5053 and 5054. There's also ephemeral ports that get created. So if you're using a stateful firewall, it should in most cases track that. You can also set the ports using the license manager tool that it uses. Again, that's not something that we typically recommend, but it should be possible to share those licenses between sites. It's pretty, we try not to do too many checkouts and too many calls to the license server to facilitate that as much as possible. So the times that you might see a delay while that checkout happens would be at initial startup, when you start a test. That's actually probably pretty much it. Maybe a couple other times, but pretty infrequent.
So one question we got, was there any package available to install on the device under test to communicate to the packet generator? And the answer here is no. The way this works is we consider that a black box. So one of the things, there's no software to be installed on the DUT. We expect the DUT to be able to communicate with Intact. So if we've had Wi-Fi devices, a lot of them, what they end up doing is using a wireless bridge. So they'll connect and put the wireless AP in bridge mode, and then they'll connect Intact to the physical box. We've also been working, lately we've been working with vendors for testing over 4G type interfaces. And in that case, again, we're working with a network simulator to allow that kind of testing, which is slightly different. But again, Intact really just needs an Ethernet port, and then it converts to whatever technology. For CE routers, for a long time, we've been using L2 VPN for doing DOCSIS, for testing DOCSIS devices has been how we've gotten around that. So the CE routers use DOCSIS. So we don't actually ever install anything on the DUT, and that's because a lot of our testing, we think that might be hard. We get production equipment that won't allow us to install anything on it. And also, lately we've been getting a lot more IoT devices, which would be very difficult to install our software on. So there's nothing that you install on it. It's actually a direct connection on a live network for that type of testing. So with that, I think we're about out of time. A couple of housekeeping things. We will post this to be available for, we've recorded this and we'll send it out later. So this way you can send it to other people on your team who weren't able to participate today. If you have any further ideas, future ideas, we will be sending out a survey for what you'd like to hear about next. We can also go more in depth with some of the packages. We've heard some people, whether it's DHCP, CE router, IPsec, any of those going forward where people want some more details, we'll be happy to go into more detail of running those testings. Each of those test suites have their own quirks, so I think that might make a lot of sense. But we expect to have them be slightly more detailed in the future. We just thought this was a good way to show off some of the new automation features that people have been asking for. And with that, I think we're all set. Tim, do you have anything else?
No, just want to thank everyone again for attending. At any time, if you have any questions, you think of something, feel free to email myself, Tim Winters, anyone on the team, or email us all at the same time by using intact@iol.unh.edu. So thanks again for attending, and we'll hope to see you next time.